Okay, final lesson in our probability chapter is called Probability of Compound Events. So, name and date. Let's see, these are probably words on your vocab sheet. It's okay if you want to write this in there, as well as this. Multiplying the probability of the first event by the multiply of the second. Dependent is the same thing, but it's following A. So you'll see that here in a second. So when we're talking about independent events, two different events are occurring in a sequence, and so one after the other. And when we work with these probabilities, we're going to multiply them. So, a couple examples here. A card is drawn from a standard deck of 52 cards. The card is replaced, and then another is drawn. Find the probability of the first card is a 3 of hearts, so there's one 3 of hearts in a deck, and out of 52. So we take that out, we didn't get it, so we put it back in, and the other one is a 2 of clubs. Well, there's one 2 of clubs, and how many cards are in the deck? There are 52 still. So 1 out of 52 times 1 out of 52, multiply straight across, is 1 over 52 squared, basically, 2,704. So that would be the probability of getting 3 of hearts and then a 2 of clubs. A prize bag contains 4 whistles, 3 yo-yos, and 9 pencils. 7 plus 9 is 16 items. Each winner of a game randomly selects and keeps one of the prizes, so they take it out. What is the probability that a whistle is chosen from the bag, followed by a yo-yo? So a whistle, there's 4 of them out of 16. We're going to multiply because we've got another event happening. A yo-yo, there's 3 of those. And how many items are left in the bag? Because the first winner took something out. There's only 15 winners left in the bag. So this is a dependent event, because this one, the second fraction, depends on what you do the first time. This is independent, the first one, because it did not, the second one was not affected. We put everything back to normal. So we can simplify here. This is 1/4 times 1/5, which will give us 1/20. So simplifying our answers either in the beginning or at the end. A couple more things to try here. A card is drawn from a standard deck of cards. The card is replaced, and a second card is drawn. So if you put it back, this is called independent events. So 4, how many 4s are in a deck of cards? Well, there's 4 out of 52. Times how many 8s are drawn. That would be, or how many 8s are there? There's 4. We put everything back in the deck of cards, so there's still 52. Okay, so we can simplify this to 1/13 times 1/13. And we get our probability, multiplying straight across. A queen of hearts, well, queen of hearts, that's 1 card out of 52 cards, times 10. There's 4 of those out of 52. Simplifying, multiplying straight across. I don't know what that number is. 676. A card is drawn from a standard deck of cards. The card is not replaced. This is called a dependent. So our second fraction will depend on our first one. Depend. So a 4, you draw 4. There's 4 4s out of 52. And then you have that card in your pocket. So there's 4 8s. So that still stays the same. But you drew a card out. So that changes to 51. So simplifying, 1/13, ugly numbers, 4 out of 13 times 51, 663. That won't simplify because nothing else simplified there. Queen of hearts and a 10, queen of hearts, there's 1 out of 52. But now we drew a card out, so there's only 51 left to mess with, and there's 4 10s. So simplifying here, I'm going to simplify diagonally instead of up and down this time, which is fine because we're multiplying. We get 1 times 1, which is 1. 13 times 51, which I have done, so 663. This one's a little bit better. You have a 4 out of 663 chance. This one's a 1 out of 663 chance. Okay, so this is where we were multiplying 2 different events happening. There's this thing called mutually exclusive events. So if 2 events cannot happen at the same time, they are said to be mutually exclusive events. If you roll 2 6-sided numbered cubes, you cannot roll both a sum of 7 and a doubles at the same time. Because not 2 dice add to 7, but it's the same. The probability of mutually exclusive can only be found by adding. So this again goes through that. The probability of one or the other of two mutually exclusive events can be found by adding the probability. So this time only one event will be occurring, but more than one outcome is a winner. So we'll be adding. A good visual of that is that if we wanted to draw an ace and a king, since aces can't be kings, these are mutually exclusive. You can't be both. We'll reference that again. So we'll try that here. A card is drawn from a standard of cards. Find the probability. A queen of clubs or a red card. So queen of clubs or a red card. Since I'm only drawing one card because that word or tells me I'm only going to draw one, and you're a winner if you get a queen of clubs, which is actually there's only one queen of clubs out of 52. Or a red card. Well, half the deck is red, so that'd be 26 out of 52. But I'm going to write it as 1/2 because half the deck is red. So when you're adding fractions, make sure you have common denominators. So I can change this to, actually I should have left it out of 52 because then we have a common denominator. 26 out of 52. If we add our numerators together, it's 27 out of 52. Keep the denominator. A queen of hearts, there's one of those out of 52. Or a 10. I'm happy with a 10 as well. That'll help me be a winner, so 4 out of 52. We're adding because, again, it's an or. Only one, you're only drawing one card. So it's going to be 5 out of 52. The spinner at the right is spun. What is the probability that the spinner will stop on a 7 or an even number? So 7, the probability is 1 out of 8, plus an even number, there's half, 4 out of 8, so we get 5 out of 8. Because we only did it, only one event was occurring, but there are two possible winners. A 6-sided number cube is rolled, so a dice, what is the probability of rolling a multiple of 3? So a multiple of 3 is 6. Multiple of 3, no, 6. Anything multiplied by 3. Yeah, just a 6. Or the number 5. Well, there's only one of those. So how many 6s are there? There's 1 out of 6. Plus, on 5, there's 1 out of 6. So 2 out of 6, which is a 1/3 or 33% chance of happening. Okay, then we have something called not mutually exclusive. Well, what happens when we have some overlap? So not mutually exclusive when both events can happen at the same time. So this one says you have A or B, so you add your events, but what if there's some overlap? So here's a visual of that. What if you have a winner where you want the a king or a heart? Well, there is one event where it can be a king of hearts. So instead of accounting for that twice, because it's once in this circle and once in this circle, we actually account for it once in this circle, once in this circle, and then just subtract one of the middle of the Venn diagram. So still only one event is occurring, but more than one outcome is winner, so we're still going to add. This works nicely with the decks of cards because there's some overlap there. So one card is drawn from a standard deck of cards. Ace is low, so one card is being drawn. You're a winner if you get an 8 or a heart. Well, so is there an 8 of hearts? And the answer is yes, so we're going to have to do some subtracting. So for an 8, there are 4 out of 52, plus hearts, there are 13 out of 52, and there's one ace 8 of hearts, so we have to subtract that overlap. So we have 4 plus 13 is 17, minus 1 is 16 out of 52, which you can simplify by taking a 4 out, so we get 4 over 13. Something lower than a 5, so something that's lower than a 5, well, there would be an ace, 2, 3, and 4 in all suits. So ace, 2, 3, and 4, that's 4 cards, but there's 4 suits, that's 16 cards out of 52. Or a diamond, there's 13 out of 52, but how many diamonds are lower than 5? Well, that would be 4 of them. So we're going to subtract 4 out of 52. And you could have just not added them in here, but we're just following kind of the formula. 16 plus 13 is 29, minus 4 is 25 out of 52. A red or a jack. Well, red, that's half the deck, so 26 out of 52, plus jacks. There's 4 out of 52, except 2 of those jacks, so I'm going to subtract my overlap, are red. So you could have just not included them here, or I'm just going to take them out here. So 30 minus 2 is 28 out of 52. Take out a 2. You get 14 out of 26. Oh, take out another 2. 7 over 13. Both primes, so I know I'm done. An 8 or a 7. Okay, so an 8 or a 7. Let's see, can an 8 be a 7? No, so these are not mutually exclusive. Or these are mutually exclusive. These other ones that we've been doing so far are not mutually exclusive. So this is a mutually exclusive, so we're just going to add, no subtracting. An 8 is 4 out of 52, plus a 7 is just 4 out of 52. So I can simplify that to 1 over 13, and 1 over 13, since they have the same denominator, and I get 2 out of 13. Can a heart be a diamond? No, so this is a mutually exclusive event. Hearts, there are 13 out of 52, plus 13 diamonds out of 52 cards. Both of those simplify to 1/4, a fourth of the deck. So we get 2/4, which is a half. Half the deck will win. A face card or a club. Okay, so can a face card be a club? The answer is yes. So this is not mutually exclusive. We're going to do some subtracting. A face card, that would be a jack, queen, or king. And then times 4 suits is 12 cards. So 12 out of 52. Plus a club, that's 13 out of 52. But how many of those clubs are faces? Well, there's 3, so I have to subtract the 3, or not included here, 52. So this is 25 minus 3, it's 22 out of 52. Dividing both by 2, we get 11 out of 26. Those are the chances of getting a winner card there. That's it for compound events. Have a great day.